We have seen how a balanced chemical equation can tell us so much about a chemical reaction. Though that is the most important part, there are other kinds of information that can be conveyed using a chemical equation. Have you ever seen such symbols under an element in a chemical equation? These symbols represent the state of the substance or the element under which they are put in a chemical equation. For example, S stands for solid, L for liquid, G for gas, and when something is dissolved in water, it's represented by AQ, which means aqueous. Also, if you see a symbol like this on the arrow, it means that the chemical reaction needs heating. For example, Fe2O3, which is solid, plus 2Al solid, gives us on heating 2Fe solid plus Al2O3, which is also a solid. Similarly, CH4 gas plus 2O2 gas gives us CO2, which is a gas, plus 2H2O in vapor form. Let's take two friends, Ed and Eddie. Ed has a salt, ammonium nitrate, and Eddie has a salt called calcium chloride. Both of the friends mix their salts in a flask of water. Ed's flask becomes cold, whereas Eddie's flask becomes hot. This is because one of them underwent exothermic reaction, where heat is liberated, therefore it becomes hot, and the other one went through endothermic reaction, where heat is absorbed and therefore it becomes cold. It's represented like this in a chemical equation. You add plus Q for exothermic and minus Q for endothermic, where the heat is absorbed. Also, in a chemical equation, when gas is evolved, it's represented by this symbol, and when a precipitate is formed, it's represented using this symbol. For example, Zn solid plus H2SO4 aqueous gives ZnSO4 aqueous plus H2 gas, which is evolved, so it's represented using this symbol. And then AgNO3 aqueous plus NaCl aqueous gives us AgCl solid, which is a precipitate formed, plus NaNO3 aqueous. So what have we learned today? We have learned how to express physical state, heat change, gas evolution, and precipitate formation in a chemical equation. Until next time, happy learning!